So in this video I wanted to talk a little bit about the mathematics and the theory behind my imaginary cube puzzle because it is quite intrinsically related to something called complex puzzles and imaginary pieces. So it's quite interesting. Now, in order to explain these concepts, I am going to use a little bit of set theory and a little bit of the terminology from that. So if you're not too familiar, I recommend just looking up quick searches on set theory just so you kind of understand what the terminology is and what it means and everything. That way this video won't be completely and utterly confusing. So without further ado, let's jump in. Ultimately, what we want to try and do is analyze what types of pieces we have on the puzzle and how they behave in the first place. And I think most people are pretty familiar with the concept of pieces in a puzzle, right? If you look at a 3x3, for example, you know you have center pieces, edge pieces, and corner pieces, and so forth. But the thing is, if we're trying to look at pieces in a general sense, you know, some puzzles don't have corner pieces. Some puzzles have pieces that are hidden. And so really what we want to try and do is generalize pieces in puzzles. We want to try to find a general definition, a rigorous definition for a piece. So how can we define a puzzle piece in the first place? Well, one way to think about what a piece really is it's something that's part of the puzzle that corresponds to something called a grip. Now, what is a grip? Well, that is essentially anything that defines a move on the puzzle. So, as a quick and rough example of this, if we think about a regular 3x3 cube, that puzzle will have the U, R, F, D, L, and B grips. And these are familiar to all of us as just the moves that you can make on a 3x3 for all the layers that you can turn and so forth. But really, these can define the grips on the puzzle. And any of these simply corresponds to one of the 6 grips. So what we can do is now use these to help us look at certain pieces on the cube. So let's just start with an example of looking at this corner piece right here. So this is a corner piece, and we can think about what moves will affect this piece. Well, just by looking at the puzzle, we can see that U, R, and F all affect this corner piece. So any of those 3 grips will move this particular corner. So what that means we can do is actually denote that corner piece with a grip signature. So what that means is that we can define that corner piece to be U, R, F. Okay? So that means that this corner piece has this grip signature. All that means is that these 3 grips will move that piece. More importantly, though, this also tells us that this corner piece does not move with the other 3 grips. And it's pretty easy to verify that. If we move D, L, or B, that corner piece doesn't move at all. So this grip signature right here tells us which grips move that piece. And the other really important thing here is that this is a unique signature. That means that this corner piece is the only piece on the puzzle that moves with these 3 grips. So in this way, we can uniquely identify and essentially index every piece on the puzzle. And another thing I should note is that really this grip signature is defining the piece position, and that's because when we mix up the puzzle, different pieces move into here, and now this is a different piece that's moving with U, R, and F. So really this defines the position, this corner position on the puzzle, but it's still essentially defining this piece type, which is a corner piece. So just something to note there. Now we can also look at other pieces. So for example, we could try looking at an edge piece. So here's this edge piece right here. And then again, we can perform the same kind of thing where we see which grips will move this edge piece. So we can see that that's going to be U, and F. Okay, and then the other 4 grips don't move that edge piece, as we can see. So we can index that edge piece like this. It'll be U, F. Pretty simple. So that's a way we can index edge pieces. And what do you notice is a little different between these 2 grip signatures? Well, this one was defining a corner piece and it has 3 grips, but this one's defining an edge piece and it only has 2 grips. And that makes sense because there's only 2 grips that move an edge piece, but there's 3 grips that move a corner piece. So the number of grips that you have in your signature is essentially telling you what type of piece you have. Now, when we get to more complicated things, you'll see that's not quite the case, but this is sort of an intuitive way to think about it. Okay? And we can go further and just finish up the whole cube. So now we also have centerpieces to think about as well. So let's look at this centerpiece. What grips make that piece move? Well, U. And that's it. The other 5 don't move that centerpiece. So that piece can also be indexed very easily, and that'll just be U. So this grip signature defines a centerpiece, and here we're only using a single grip, which makes sense because centerpieces, they only rotate in place, and that makes sense with what we're defining here as our grips. Now, we can even go a little bit further and think about the core of a 3x3. Right? Because really, if you think about it, the core is in the center of the cube, and really it's a piece of the puzzle. And so we can also think about trying to define it using this grip signature, right? Well, if we think about the core, if we move any of these grips, the core is always fixed. It never moves at all. It never even rotates in place, as long as you're not rotating the whole puzzle. Then the core just stays fixed in place. It never moves with any of the grips. So for the core, we can define that to be the empty set, which simply means that it's a set without any elements in it. It just means that we're not using any of these grips at all because none of these grips move that piece. So this is a way that we can define the core of the 3x3. And in fact, the core of any puzzle can be represented as the empty set. But why stop there? What we have here are these grip signatures that are defining all the piece types we can find in a 3x3. But if you think about it, we could, make a set using any of these 6 grips here that we want to. We could, for example, maybe define a grip signature that's UD or something like that, right? Well, if we think about this grip signature here, this is telling us that we have a piece type which moves with the U grip and the D grip and doesn't move with the other 4 grips. But on a regular 3x3, that doesn't exist. There is no piece that moves with both U and D and doesn't move with the other 4. We don't have that. So does that mean that this piece is impossible? Well, we can still define it to be this way. Even though it doesn't exist on a regular 3x3, we can still define this to be a piece on a more general puzzle. What is that more general puzzle? Well, it turns out to be what's known as the complex 3x3. And the complex 3x3 as a whole is basically looking at every single possible grip signature that you can make with this grip set, I guess. And the collection of all of those possible grip signatures actually represents the complex 3x3. All possible ways that pieces could move with these grips. Now, if you want a more mathematical terminology for this, if we call this grip set here G, then we can define the complex 3x3, which I'll just denote as this fancy C, as the power set of G. And that simply means looking at the set of all subsets of G. So every element in the power set of G represents a single piece position, really. Remember, we're looking at positions again, of the complex 3x3. And how many pieces are in the complex 3x3? Well, the nice thing is to count cardinality of a power set is pretty simple. It's simply going to be 2 to the power of the cardinality of G, which is 6. So that means there are 64 pieces in the complex 3x3 in total. So this is, of course, getting a little bit more abstract. You know, not all of these pieces really can exist in the real puzzle. And to distinguish between those weird pieces and the regular pieces we're used to, we use terminology such as real pieces and imaginary pieces. So the pieces that you're familiar with on a regular cube, centers, edges, corners, as well as the core, we call those real pieces because they're real and they're here in the puzzle. And we call all of those weird pieces that behave in strange ways that don't really exist on a regular 3x3, we call those imaginary pieces. And because it kind of relates to, you know, real and imaginary, you know, parts of complex numbers. That's kind of why we have this terminology. I didn't make this up. This is just kind of how it came to be. All right, so now what did all of that have to do with the imaginary cube? Right? Well, this is, again, another puzzle that it looks sort of similar to a 3x3, right? You still have these 3 layers kind of across each axis here. And, you know, what exactly does those grip signature stuff have to do with this puzzle? Well, we used that grip signature technique to analyze the pieces on a regular 3x3, so let's try and do the same thing for this imaginary cube. Let's try to look at all the pieces we have on this puzzle and see if we can define them using grip signatures and see what we get, right? So let's first start with what pieces we have on this puzzle. We have this bandaged corner block here, so there's this piece type. We also have these pieces in the center right here. These in fact are not centerpieces. It's a little more complicated than that, and we'll see that in a minute. We also have these little wedge pieces in the circle. We have these little triangles in the circle. And we finally have these what appear to be outer edge pieces, and then what appear to be corner pieces here. So we have a total of 6 piece types, apparent piece types in this puzzle that are visible to us. So let's think about how to analyze this now. So remember, with the way that this puzzle turns is that we can only look at turning the layers that don't contain this bandaged corner block. So we're only looking at turning double layers at any given time. Now, intrinsically, because this is a bandaged puzzle, I mean, you can see that right here, we will sometimes need to move the core of the puzzle around in order to access all the possible grips. But this puzzle does have the same grip set as the regular cube. It's still that grip set that has, let's write this down again. So our grip set, let's define that, is still the same thing. Order doesn't matter here. So we still have the same grip set for this puzzle that we're going to use to analyze it. So let's, first of all, let's start with looking at this bandaged corner piece right here. What is this piece really? Well, remember that we can only turn the double layers like this. So if you think about looking at this piece, if we turn this layer here, which I'll call this F, this U, and this R, just to clear up any confusion, we turn F, it doesn't move. We turn U, also doesn't move. And if we turn R, it also doesn't move. So it's not moving with any of these grips really. And to really see that it's not going to move with anything, remember we can only turn double layers. So to access the other layers, what I'm going to do is move this a little bit. So now it's kind of right here. So now we have L, it still doesn't move. D, still doesn't move. And B, still doesn't move. All right? So that piece here doesn't move with any of our grips at all. Well, you know, that sounds a lot like the core of the 3x3, where it didn't move with any of the grips at all. So as it turns out, this bandaged corner piece right here is actually the core of the puzzle, and it's visible. Pretty interesting. So that's the core. So we've already looked at that piece. So we have the core of the puzzle, and that's simply the empty set, as we've seen before. Okay, now let's move on to another piece type. Let's look at these little triangles in the circles here. Let's take a look at that. Let's look at this one as an example. Actually, let's look at this one right here. Yeah, this makes more sense. So if we look at this triangle, we want to look at what grips move this piece, as always. Well, let's try F and see if that moves it. No, it doesn't, because remember, the circles stay fixed when you turn the double layers. So F does not move this piece, okay? So let's try U. Yeah, U moves this piece. Let's try R. Yep, R moves this piece. And now I'm going to move the core a little bit. Okay, let's move it there. So now let's try D. Nope, doesn't move this piece. Let's try B. Nope, also doesn't move this piece. And the last one to look at was L, but I think that one's pretty obvious. L does not move that piece. So ultimately this piece moves with U, and it moves with R. Okay, so that means that for this piece, our signature here, which I'm going to actually write down first, is UR. Well, wait a second. That looks oddly familiar to something that we saw before with the regular 3x3. So let's pull that out again. So if we look at a regular 3x3, let's try moving these grips and seeing if we see anything that's moving with only those two grips. Well, let's move U, and let's move R. Take a look at this edge piece here. If we move U, it moves. If we move R, it also moves. But it doesn't move with the other four. So what we have for this grip signature for that triangular piece that we saw seems to be exactly the same as the grip signature for a regular edge piece on a 3x3. And it actually is. It turns out that these pieces are functionally equivalent to each other. So this triangle piece actually represents an edge piece on the 3x3, which seems absurd at first because it's not even on the edge, but it turns out it's true. This piece represents an edge piece on the 3x3. So we actually do have a representation for an edge piece. So you have the regular 3x3 edge pieces in this puzzle. Even though it's not these ones, it's actually these triangles here. Pretty crazy. Now another thing we can look at is the triangle piece on the opposite side of the puzzle. Now why would we want to look at this? Well, just to see what happens. So let's try moving those grips again. If we move U, yep, this piece moves. And if we move R, yeah, this piece also moves. So far it seems to behave the same way. And if we try to move F, nope, doesn't move. If we try to move L, nope, doesn't move. If we try to move D, doesn't move. If we try to move B, it doesn't move. So there we go. It moves with just these two grips and not with the other four. So it has exactly the same grip signature as this piece. What does that mean? Well, interestingly enough, that tells us that in fact, these two pieces, since they have the grip signature that's identical, they actually behave as a single unit. So these pieces here that apparently seem to be separate from each other are in fact connected. They will never separate. So that's quite an interesting fact here, is that if we have multiple that apparently different pieces on the puzzle that share the same grip signature, it actually means they're not different pieces. They actually are connected and physically move as a single unit. So there we go. The 3x3 edge pieces are represented in this puzzle because it's not only this triangle but also an opposite triangle that represents a single edge piece. Well, another obvious one to look at are these what look to be corner pieces, right? So let's look at this corner piece right here. Let's see what grips it moves with. We have U, yep, that moves. R, yep, moves. F, indeed it moves. And if we look at the other grips, let's try D. No, it doesn't move. B, no, it doesn't move. And finally, the last one I think is pretty obvious. If we look at L, still doesn't move. So that means that the grip signature for this piece right here is going to be U, R, F. Well, that seems oddly familiar, and actually, when we looked at the corner piece on the 3x3, it also moves with those 3 grips, and it doesn't move with the other 3. So it turns out that this piece, which looks like a corner piece, actually is a corner piece. So we do have the 3x3 corners in this puzzle. Let's learn to spell here. Okay, so we have a core, we have 3x3 edges, we have 3x3 corners, but we have a lot of other pieces here that we want to look at, right? We've got all these pieces. So let's try analyzing these. Let's first start by looking at these, what look like centerpieces, right? What on earth are these? Well, again, let's look at this grip analysis. So let's see what grips this piece moves with. Let's try R. Yep, it moves. U. Yep, it moves. Now I'm going to move the core a little bit so we can access these other grips. Let's look at L. Yep, it moves. D. Yep, it moves. So it moves with those 4 grips. Let's try F. No, it doesn't move. As you can see, the circle stays fixed in place. So F does not move it. Let's put it back now. And B, just as the last one, no, doesn't move. Okay, so these, what appear to be centerpieces, actually are behaving completely differently. They're moving with a lot more grips than a regular centerpiece would. So for these pieces, we're going to say that our grip signature is U, R, D, there we go, L. So it moves with those 4 grips and doesn't move with the other 2. Well, what on earth are these pieces? Like, look at this grip signature here. That's definitely not on a regular cube, but here it is on this puzzle. Pretty interesting. So what's a way to think of these pieces? Well, if we look at what we had here, if we think about these 4 grips, those 4 grips are all along an equator on the puzzle. If we think about this as being the one piece we were focusing on, we have U, R, D, and L. So these 4 grips are all around this equator right here. Now another thing we can think about is what were the grips that weren't used? Well, we didn't use F and we didn't use B. Now if we think about those grips, F and B, those grips are on exactly the same axis of rotation on the puzzle, F and B. So what we have here is the opposite of that. We have all the other grips that don't, if we pick a single axis, don't lie on it. So a terminology that we can use for these pieces is inverse axis pieces. We're going to say that this grip signature represents an inverse axis. So there's the first really weird piece type we've encountered so far. Now we have 2 more to go. So now if we look back at the puzzle again, we also have our edge pieces here, what we think are edge pieces. So let's try analyzing these now. So we know that these can't be edge pieces because we already found out that the triangles represent the edges. So what on earth are these going to be? Well, let's just look at what grips move this piece here. So we have U, yep, it moves. R, yep, it also moves. F, yep, it moves. Now I'm going to move the core a little bit. L, yep, also moves. Let's try moving D, does not move. And B also doesn't move. So this piece moves with 4 grips again. Well, hang on, is that going to be the same as this? Well, let's write down what those grips were. So that apparently edge piece moves with U, R, F, and L. Well, now we can see that these are not the same grip signature because right here we had opposite grips here and opposite grips here. But in this case, these 2 grips are not opposite each other. These ones still are, but these ones are no longer opposite each other. So this is a different type of set of 4 grips for this piece. So it's not going to be the same as this inverse axis piece because it's different locations for these grips that are moving that piece. So what piece is this? Well, again, what we can try to do is think about what grips were not used here. So those would be D and B. Well, let's pull out our 3x3 again and see what moves with those other grips. So we want to look at what moves with D and what moves with B. So if we move D and we move B. Well, look at that. If we move D and B, they both move this edge piece right here. And this edge piece is clearly not going to move with the other four. But those other four are these grips right here. So if we think about it, these grips are what don't move an edge piece on the regular 3x3, but those four grips are clearly what are only moving this piece. And the other grips that aren't used, that don't move this piece, are moving a regular edge piece. So what we kind of have here is kind of like the opposite of an edge piece grip, right? If this grip represents a regular edge piece, then these grips are representing the opposite of that. Well, that's kind of like an inverse edge piece. So as it turns out, this grip signature is representing an inverse edge. So now this is wild. If we look at this, we have both regular edge pieces in the puzzle, and we have inverse edge pieces in this puzzle. We have both the regular piece type and the inverse piece type both present in the same puzzle. And when I first released this puzzle and first designed it, this was probably one of the first puzzles to have this property where we have both the regular piece type and the inverse piece type, which is pretty complicated. So there we go, we have 5 piece types down. Now there's one more to look at, and that was these wedges right here. So what piece type are these? Now let's again perform that grip analysis. Let's see if this piece here, let's look at what moves this piece. So let's look at U. Yep, moves that piece. Let's look at R. Yep, moves that piece. Let's look at F. No, it does not move that piece. Move the core a little bit. Let's look at L. Yep, it moves that piece. D. No, it does not move that piece. And B. No, it does not move that piece. So what we have here are 3 grips that are moving this piece. Well, there it is again. We've got 3 grips moving a piece. Is this going to be a corner piece again? Well, let's write down what that grip signature was. So for that particular piece, we saw that it was U, R, and L. Yeah, these are different grip signatures. For this one, we had all adjacent grips, but in this one, we have 2 opposite grips that are in the signature. So this is, again, going to be a different piece. It's not going to be a corner piece. So what on earth is this piece? Well, if we try to think about what the grips that weren't used are, those are D, F, and B. But again, that doesn't really help. If we think about D, F, and B, we'll just write it down. It's almost kind of the same as this, right? Because we have 2 opposite grips and then 1 adjacent grip. Just like with this one, 2 opposite grips, 1 adjacent grip. So what is that telling us? Well, this kind of gives a little bit of a clue here in that these pieces aren't present on the regular 3x3, obviously, but the inverse grip signature also doesn't represent a piece that's in the regular 3x3. This piece is a really strange one. And because of this property where we look at that inverse grip signature and it still represents another piece on this puzzle, then let's look at what this piece actually is here. Let's see if we can find it on this puzzle, because if it's here, then that'll give us a clue. Okay, so let's try it. So D, F, and B. And we want to look at what piece moves with those grips there. So let's look on the bottom here. So D, B, and F, You know, I think it might be this piece right here. So let's check. So D, yep, moves with that grip. F, yep, moves with that grip. And remember, we're only looking at positions, not actual pieces, so that's still fine. We're still looking right here. B, yep, moves with that grip. So there we go. So it's this piece here that is represented by the inverse grip signature. Well, look at that. It's this piece. That's the same piece as this one. It just is a different location on the puzzle. So what that tells us is that even if we look at the regular grip signature or the inverse grip signature, it's still going to refer to the same piece type. And that's actually because we have 3 grips in the signature, which is half as many as in the grip set. So that's just why that happens to occur there. Now, what are actually these pieces? Well, the interesting thing is these pieces don't show up on a regular 3x3, and the inverse grip signature piece also doesn't show up on a regular 3x3. So this is actually a brand new piece type. For a long time, this piece type had actually never been physically implemented in a puzzle before, and this was the first puzzle to do that. This is a brand new piece, and we can't even represent it as like an inverse or regular version of anything on a 3x3. So we had to come up with a completely new name for this piece. So some of the terminology, at least the old terminology, used to call this a T-piece. But more recent terminology has called it a tri-wall. So this piece type goes by a few different names, but ultimately what we have here is a brand new piece type. This is something that's not on the regular 3x3, something that its inverse grip signature doesn't represent on a regular 3x3. It's a brand new piece type. And here it is in the puzzle. And this is definitely an imaginary piece, because it's certainly not a real piece. So this is what's really crazy, is that this puzzle has real pieces and imaginary pieces. And these are all pieces that show up on the complex 3x3. Now this is not all of the pieces in the complex 3x3. There's still quite a few that we're missing. For example, the anti-core, I guess you could call it, would be the entire grip set itself would represent the anti-core. Imagine a piece that moved with every single grip. That would be the anti-core, though that's not in this puzzle. So there's still not every single piece from the complex 3x3 in this, but what we see here is that we have a lot of really interesting piece types that definitely don't show up on a regular 3x3, but are actually part of the complex 3x3. So on the left here we have our 3x3 pieces that we're familiar with, and on the right here we have all of our imaginary piece types. So we have 3 real piece types and 3 imaginary piece types that are in the imaginary cube. So hence the name. This is why I named this puzzle the imaginary cube. It has imaginary piece types. One of the first puzzles to implement some of these imaginary piece types. Alright, so I hope that explains a little bit about the theory behind the imaginary cube. It is quite an interesting puzzle to think about, and you could look at it as a subset of the complex 3x3, or you can look at it as a really weird circle cube, whatever suits your fancy. But I hope you found this interesting, and thanks for watching.